Hello everyone, welcome to Online Maths TV. Today we have a challenge on logarithm, a very simple one at that. It's not all the time we rack our head for solving challenges. Okay, today we have a very simple one that at a glance you can solve this. It's for beginners anyway. But if you're new here, do not forget to subscribe. Okay, because at Online Maths TV, we drop wonderful videos all the time for your learning, for your fun. Okay, all right, so let's go into today's challenge without much waste of time. The question reads, solve for x. 1 all over log into your x minus 1 close bracket plus 2 all over log x to the power of 2 equal to 0. So without much waste of time, let's take our solution here. So we have solution. All right. The question is 1 all over log your x minus 1 close bracket plus 2 all over log your x to the power of 2 equal to 0. The number one thing we're going to do here is very easy. We just have to rewrite this. Apply the law of logarithm. Okay, so the law of logarithm, which says that if you have, let's assume you have your log p to the power of k, this is an exponent, move it backward. So if we do this, this will give us k dot your log, your p, right? So if we apply this law, then we can rewrite this expression as 1 all over log your x minus 1, okay, plus your 2 all over 2 log your x, because we're moving this exponent backward here now. Okay, so if we do that, at the numerator we are having 2, and here we are having to do this, and this leaves the system. We now end up having 1 all over log our x minus 1 close bracket that plugs our 1 all over log x. Okay, here is equal to 0, here is equal to 0. Okay, so let's look at this again. At this point, we can now look for the LCM of this and this. And what is the LCM? The LCM is going to give us the product of the two entities we have here. Okay, so if we do that, this will now give us log x minus 1 dot log x. Okay, as our LCM. All right, so from here, we use this denominator to divide the LCM. And if we do that, we are left with log x. So we're going to have here log x plus, if we use this to divide this, we are left with log x minus 1. So plus log x minus 1. Okay, it's a simple arithmetic. When we use this to divide this, we left with log x. Log x times 1 will give us log x. We use this to divide everything here. This will cancel out, so we are left with this, and this times 1 will give us this. This is equal to 0. All right, so let's continue on this side of the board. Now, if you look at the numerator, we can apply the product law of logarithm here. You know what it says, right? Okay, so if you apply the product law, then it's going to give us here log your x into your x minus 1 close bracket, okay, all over your log your x minus 1, then dot log your x, this equal to what? 0. All we need to do is just to multiply by the denominator. And if we do that, then we are left with log your x into x minus 1, then equal to 0. Easy. So what we do, here we are having 0, and here we are having a log function here. So we have to introduce a log function here. This is log base 10. So we have to introduce log base 10 here. Okay, another law of logarithm says that if you have log 1 base 10, that will give us 0. Remember? Okay, as a matter of fact, I produced a video on the 7 major laws of logarithm, and the video is showing up here. Okay, so you can watch that video to see the 3 laws of logarithm I have applied here. I applied one here, I applied another one here. Okay, then and I applied another one here now, okay, which is from year to year. Okay, so you can watch that video and see some of the simple rules or laws of logarithm. Okay, so if we go by this law, then we can rewrite this part of the equation. So this will now give us log x into your x minus 1 equal to log 1 base 10. This is also base 10. All these are in natural what? Base, okay? So we have log this base this and log 1 base this. So this leaves the system. So we are now left with our x into x minus 1 equal to 1. Just open up this and there you are good to go. So this now give us here x squared minus your x equal to 1. Bring this to this side of the equation to give us x squared minus x minus 1 equal to 0. Now, what kind of equation is this? This is a quadratic equation. So all we need to do is to solve this quadratically, because if we have to use the factorization method, that may give us some tough time. And so using the formula method straightforward, we get our ABC. From our equation, the quadratic formula, which says that your minus b plus minus the square root of b squared minus 4ac all over 2a. All we just need to do here is just to bring the value of ABC from this our quadratic equation. So from here we have our A is equal to positive 1, B is equal to minus 1, C is equal to minus 1. Let's go ahead and substitute this into this formula and see what this gives us. All right, so again, we substituting, we're going to have our x is equal to minus into minus 1 plus minus the square root of, again, b is minus 1, so we have minus 1 all to the power of 2 minus 4 times 1 times minus 1. Okay? All over 2 times positive 1. This will now give us plus minus into 1. Square root of minus 1 is 1. Then minus times minus gives us plus. Then here we have 4 all over your 2. Again, we have here 1 plus minus the square root of 5. 1 plus 4 gives us 5 all over 2. So we have two solutions here. We can split the two to give us our x1 is equal to 1 plus the square root of 5 all over 2, and our x2 is equal to 1 minus the square root of 5 all over 2. Now you discover that one of the roots, one of the solutions to this logarithm equation is a golden ratio. Okay, so this is our golden ratio. One of the roots is a golden ratio. Okay, so this marks the end to this simple logarithm equation. And if you learn something from this video, however simple it may be, then give the video a thumbs up. And again, if you're new here, do not forget to subscribe. This is Online Maths TV, where we learn mathematics all the time. Remember, my name is Jakes, and I love you so much. Even everyone at Online Maths TV loves you dearly. Thanks for always be there. Bye for now.